many beautiful faces. They didn't warn us that our listeners, we know a lot about the demographics, but I didn't know about the beauty thing. Okay, thank you all for coming out. Thank you, Caveat, for having us. Welcome to our second installment of Viscera, gripping, even visceral tales of the human body with ER doctor Avir Mitra. I am Lulu Miller, one of the co-hosts of Radiolab. And before I bring out our star storyteller, I just want to talk a little bit about what's going on. First of all, I'm achieving a lifelong dream of sharing this stage with an animated breast, dripping breast milk. So let me just take that in. Okay, second of all, if you've listened to, that's what it is. If you've listened to Radiolab, you know that we like the music and the sound design. And our director of sound design is this tall man with the upright bass, Dylan Keefe. If you've had a pretty moment listening to something and you're like contemplating and you're enjoying the space inside your head with a musical undertone, that is because of him. And he has brought with him his friend, musician Ivan Berenbaum. How did I do? What's better? Ivan Berenbaum. To play some winds. And while we are usually a highly edited, like borderline pathologically tweaky situation, we're trying to make a Radiolab episode live for you tonight. Harry said, go up more to the front, because they don't usually, okay. So they will be live scoring. You'll see some hand signals like, bring up the music. And then we're going to just like close it down. And I don't know, we'll see how it goes. It's going to be a peek behind the curtain. And so, to really kick us off, we have quite an adventure ahead. If you've listened to Radiolab, you have likely heard the voice of Dr. Avir Mitra. He is such a voracious storyteller. In addition to saving lives in emergency rooms in the city, just down the street, he can't stop thinking about why our medicine got here, the strange stories, the strange people that brought it to us, how our body functions. You've maybe heard him tell stories about vultures predicting strange human health crises. Maybe you've heard him tell a story about a life-saving compound illicitly smuggled over borders in a very old yogurt container. And tonight, he assures me we are going to travel around the globe, back into the past to encounter one of humanity's oldest friends, a friend that we lost. But tonight, for those of you who dare, with your consent, we will be reunited with via ingesting it through our mouths. If you want. Okay, but we're gonna get there. Don't do it. You don't do it yet until we cue you. Without further ado, Avir Mitra, can we get some bring on music?
Thank you. Thank you. Wow. Thank you so much. Wow, a lot of people on a Tuesday. I love this. I'm so glad you guys are here. So, the theme of this show is viscera. It's like things inside of your body that you didn't really think about or know about. We look at them in different ways. Last time we talked about the heart. Today we're talking about something that's never really been in my body, but it's probably been in some of your bodies. But right now, it's definitely in your body. We're talking about the magical substance that is breast milk. Just pumped, like before we got here.
Yes, okay, so I have, this is in my body at the moment. I have an 8-month-old. I am breastfeeding. I also use formula. We're not here to say one or the other is better. But instead, there are strange things inside this substance that is as old as mammalian time.
Yeah.
And I guess you're going to tell us what.
Well, I think that's the thing. What inspires me is to think about all these different types of diets. Should we be eating keto? Should we be vegan? We don't really know. But we only have one clue left by nature about what Homo sapiens should eat, and it's breast milk. We know that this was designed for at least babies. So do we really know, what's in here? Have we really thought about everything that's in here? I guess I'm going to throw it to the crowd. If we just had to name the components of breast milk, And I'm going to take one off the table. We know that it's 87% water. Okay, fine. That's easy. But the solid part, like, name some things. What's in breast milk? Vodka.
Depending on the mother's
Yes,
night.
yeah, right. Fat. Sugar. Proteins, hormones, calcium. Antibiotics.
We heard amino acids.
Amino acids. Yeah, you guys are right. I mean, everything you're saying is right. But there is something that we've missed. And to be fair, I went to med school for way too long, and I didn't know about this either. It's called human milk oligosaccharides. HMOs for short.
HMOs, not my medical plan.
No, not your medical plan.
An abbreviation for weird. Okay, so oligosaccharide. I'm feeling saccharin. I'm feeling sugar.
Exactly.
Vibes?
Yeah,
Okay.
these are sugars. And what's
Okay.
crazy is probably most of us have never heard of this term, but it's actually the third largest compound in breast milk, way above protein. So, you have
Whoa.
lactose, that's the sugar that someone mentioned. You have lipids, that's fat. And then you have these HMOs, which none of us, I don't think any of us really talk about it. And then you have protein.
That's bizarre.
It's just kind of weird that we don't talk about it.
Yeah.
And I think it's even weirder because, just to tell you why I think this is weird, how can I put it? So everything you've ever eaten, right, like every sugar, every sweet thing, every carbohydrate, every starch, is essentially made up of like 3 basic building block sugars. I'm going to name them for you here.
Glucose.
All right, you got glucose.
Are these the technical drawings?
Yeah, these are chemical structures.
Okay.
Galactose.
Okay. So, like just for example, table sugar, that's a glucose mixed with a fructose. Or honey, that's like chains of fructose. Potato chips, like just a bunch of glucoses together. You get the idea. Everything you've ever had is one of these things.
Avir, why do they look like this? You made
I
the
was just-
slideshow.
I was literally laying in bed and just started thinking about these guys as Nintendo Wii characters. I don't know why.
Just like boring Nintendo Wii. Okay.
I don't know. It just
Okay.
felt
Into
right.
the Avir's mind. Okay.
Yeah.
So these are like the sugars we see in the world?
Yeah, these are. This is every carbohydrate you've ever had is one of these, and
Okay.
then you have these HMOs, and they are strange.
Fucose. Nana. Glicknac.
Okay.
Wait,
I'm
these
not-
are the real names?
Yeah, those are the names. I'm not making
Okay.
those names up. I mean,
Okay.
they're weird. They're alien sugars. Like it's literally as if like you had an alternate reality where you still have caveat, but it's spelled differently. It's a totally different caveat. Or
Okay.
you have everything, just a different version of it. There's
Can-
these 3 different sugars. And what's crazy about it is they sort of combine into these weird shapes.
Does
and
it feel
chains.
like we should get some like mysterious alien sugar music?
Yeah, we should.
Okay.
We should get some music. Yeah, exactly. So these sugars, right?
Yeah.
They're very strange. You've never seen them. You can't get them at the local grocery store. You've never tasted them. They combine into these weird branches and chains, and ferns and weird shapes. And those combine together into even weirder shapes.
Whoa.
Beads, forests.
And are these other places in nature? Like, are they out in
No.
honeysuckles or I don't?
No.
Just
in milk.
would they be in dolphin or cow, other mammal breast milk?
Yeah, they would be. They are
Okay.
in every type of mammal makes these, but humans make the most.
Okay.
But here's what's weird. Humans can't digest this stuff at all. Like literally, no human being can do anything with these sugars. They go in you and they go right out of you.
Wait, so this huge amount of breast milk, which like that takes freaking time to pump.
Right.
A huge portion of it just, if a baby eats it, not using it, not turning it into like energy, just.
Yeah, exactly. And I know when some of you guys walked in, you may have picked up some drinks.
Yeah.
Those
Yeah.
are HMOs. So can we get some up here? I want to try. I've
okay.
never tried this before. I've been saving it.
Okay.
Oh, it's back here?
Oh yeah, where are? Oh, it's already pre-dissolved. Is this okay?
Is
So
this it?
okay, so we're getting to taste this sugar that
So
you
if you
don't
wanna try
find.
them-
If anyone else wants to try it, so it's sugar that's found in breast milk, and we don't know what it tastes. Well, you haven't tasted it yet, right? Cheers, chin chin. Okay. Barely. It's like it almost tastes like really fresh water. How like really fresh water tastes a little sweet.
I guess so.
I don't
yeah.
know. What do you think? Any
I think
other?
I'm imagining something. I'm not sure. Do you guys taste anything?
Also, can I
Yeah?
get audience help? Because I didn't mean for my dress to unclasp. This isn't like a live breast pump situation. It's not where this is going. Yeah, can you just come over? Okay. Anyway, okay, so...
Ellen Horn,
Ellen
original-
Horn, OG, executive producer of Radiolab. Still here to make things run smoothly. Okay, continue. Okay.
So here's the thing about these HMOs. I'm going to call them alien sugars that you guys just tried. They've sort of been written out of history, right? Like none of us ever thought about them. They're sort of written in the sidelines of textbooks, and I don't know. They're not in formula, so it's really just like a nobody. And no one ever really thought to ask like what's going on, really, until a scientist by the name of Bruce German came along, and basically just asked a simple question.
What's that question?
The question is why.
Can we get some why music?
We need some why music.
Okay.
So, like, why would a mother who's got very precious, limited calories, why would that mother literally dissolve her own body, taking all these precious nutrients and calories to make milk that needs to feed this baby? Why would the mom make these sugars that no baby can use? Why?
Should I get could it be waste? Could it be waste? Could it be some byproduct of some metabolic function?
Well, Bruce is considering that. He's
Okay.
asking this question, and certainly it could be a waste product.
Okay.
But Bruce has this hunch that like nature, human nature, evolution is just like too perfect. It's
Yeah.
too perfect to create all this waste. Like
Yeah.
Lulu, you are too perfect to be creating a waste product in your breast milk. Your
Thanks.
breast milk is way too good to be
Okay.
creating all this waste.
All right. So he thinks there's a reason. He thinks it's not waste. He thinks there's a reason.
He thinks there has to be a reason.
But again, humans can't do anything with it.
Humans can't do anything with
Okay.
it. So that we know of.
That we know of.
So this is around 2005,
Our
2006.
fact checkers are in the audience tonight.
We're gonna put you on the salary. Oh, we got Robert Krulwich in the audience, guys.
Robert Collins!
The legend, the Godfather. All right.
He looks so tan.
Okay.
Okay.
So this is around 2005. Bruce is having these thoughts, and this is the era sort of the microbiome, where we're all thinking about the microbiome. And it's this idea that we've been spending the last 100 years trying to become clean and sterile, but actually we're completely surrounded and completely covered in bacteria at all times. This is that idea that's persisting that wow, it really turns the idea of cleanliness on its head. We're basically human suits covered in bacteria, filled with bacteria, And so he has this
I like
hunch
that
that
image so much. Sorry.
yeah, he has this hunch that's basically like, okay, well, if we can't use it, maybe there's a bacteria that can.
Huh. Okay, so maybe like a bacteria
Yeah.
in
That
where?
lives inside of a baby. Maybe there's a bacteria that lives in the baby's
That would make sense,
gut.
like a puzzle piece.
Right.
Food for a baby bacteria.
Right.
Okay.
But here's the problem.
Yeah.
There's 36 trillion bacteria in the gut. Okay, just to put that in context, if you took
Okay.
every human on Earth and then took 5,000 of those Earths,
Yeah.
that would be how many bacteria live inside of each one of you.
That
I mean,
he
that's
would
a
have
lot.
to audition to find out if it's eating it.
Exactly. It's
Okay,
just
that
there's
feels
thousands of species.
Computationally difficult.
Right.
Okay.
So that's the problem. But so they decide to, I just took this from a textbook. I mean, this is just like
What is-
one page of a textbook of the different bacteria that we know exist in the gut. I mean,
Whoa.
you don't have to read the names. It's a lot of names.
Can we read some of the names?
Yeah.
Eugothelenta, Eubacterium, Ventricolium,
Yeah, that's a good one. He's a good guy.
Clostridium leptum. Okay, so you're saying times like 5 trillion million.
Exactly.
Okay.
So
Okay.
they design an experiment, basically taking an agar plate where bacteria like to grow.
Okay.
So they decide, okay, we'll take an agar plate, we'll get some breast milk, take all the normal stuff out of breast milk, just keep the alien sugars.
Okay.
Sprinkle the alien sugars on the plate, and throw a bacteria in there and see if it grows.
Okay, it's like sink or swim. It's like if you eat it, you'll proliferate. If you don't, you're gonna die.
Exactly.
Okay.
Yeah,
All
you
right.
got it. So that's the idea. So
That's
they
the
throw
experiment.
some bacteria, take a common bacteria that lives in the gut, throw it on there, throw some HMOs, it dies. Doesn't work. No luck.
Okay.
Try another one, no luck. Try a third one, no luck.
Luckily, they only have 37 trillion.
Well,
to go?
yes.
Okay.
It's a long ways to go.
Okay, how long is this taking?
Well, so a year goes by.
Yep.
Bruce and his team are like begging, borrowing, and stealing to get like any bacteria or any, breast milk that they can, begging on the street, like, can I get some? It's not working. A year goes by. 2 years go by.
Okay.
And finally, on the third year,
Yeah?
boom, they find something.
Okay, can
I
we-
get a little...
Dum, dum, dum.
That was perfect.
Ooh!
Wow. Why do we prep for these podcasts? We could just do this.
I know,
This
let's
is
just
great.
always do that. Okay.
Okay, so they find something that's growing. You could see all this white stuff is bacteria that's growing. Let's get a
Okay.
little ominous music. I want to zoom in because they put it under a microscope and it looks very strange.
Ooh,
Zoom in a little more.
it's beautiful.
Zoom in a little more. A little more.
And so this is the bacteria that likes to eat the weird alien sugar in the breast milk.
Exactly. And so it turns out this bacteria is
Yep.
called Bifidobacterium infantis.
Bifidobacterium, that's so cute. Okay, word nerd, bifid, bifurcate. You got that Y shape?
Yeah,
kind of?
exactly. It's got a
Okay.
Y shape. And this is a bacteria that was known. It was actually discovered by some guy in 1899. He sort of saw it, wrote it on a list, and forgot about it. So it's just been sitting around in the back of someone's textbook for a long time.
Okay.
Yeah. So,
So-
yeah.
Okay, so does that mean this is in my baby's belly?
Well, that's the next question. Exactly right.
Yeah.
So you found out of the thousands of bacteria, you found one that can eat these sugars. That's crazy enough. Because
Yeah.
we can't eat them, but it has all the genes and all the enzymes to eat these sugars that we make that we can't eat. It's just weird, right?
Yeah.
So you would think, okay, this should be in some baby's guts.
Yeah.
And so the way to look for that is, when you have bacteria in your gut, you're going to poop out some of that bacteria. So you really got to get into poop. That's where this story is going. And so basically from there, Bruce and his team need to start collecting dirty diapers, which I don't know if that's an upgrade from begging for milk, but that's where they're at. Don't be offended. Someone's going to be offended, I think, but this is, the ChatGPT made this. I didn't do this. So Bruce is working at UC Davis. He's around getting his friends and neighbors and strangers on the street to give him their dirty diapers. Let's culture it. Let's see if we can find some bifid in there.
Yeah.
But no, he can't find any bifid in any of these diapers.
They're just not. So that theory gone?
Well, it might just be where they're located, So they realize they need to sort of expand the search. And that's
Okay.
where this idea starts, what I call the amazing global baby diaper hunt.
Okay.
So it turns out that the Gates Foundation, for some reason, has collected stool samples from all over the planet. I'm not sure why.
Okay.
But don't tell Elon Musk about this, please.
Basic science! You never know.
So they have just baby poop, like just lining their walls, I guess. I don't know.
Just libraries of poop.
Just libraries of poop from
Okay.
all over the world. So
Yep.
Bruce calls them, sets up a meeting and says, "Can I get some of this? Let me get some of this poop." So yeah, they set up a deal where
Okay.
they're gonna send him poop from all over the world, and they're gonna
Okay.
look all over the place. So they
Yeah.
look. They start looking at poop in Denmark,
Okay.
and no bifid.
Okay.
Scandinavia, Switzerland, no bifid.
Okay.
But then they get to Gambia,
Huh.
bifid. It's there in the poop. Cambodia,
Bifid?
it's there. Rural China, Bangladesh, they have bifid.
Huh.
Weirdly, the only people in the U.S.,
Yeah.
Mennonites.
Mennonites
have
have the bifid. The babies have it.
Very strange. Yeah.
Am I allowed to
Yeah.
why some places and not others?
Well, that's the question. At this
Okay.
time, they don't really know why here, why not there.
Yeah.
It's a mystery. I mean, it certainly could be, maybe this bacteria survives in a certain climate. Maybe it's genetic differences. Maybe it's lifestyle differences. It's an open question.
Okay. Does he have any guesses of there's obviously some bacteria we like that are great for gut health, some we don't want. Does
Right.
he have any sense of what it's actually doing?
Right, that's the next question. Is Bruce and the team, guy by the name of David Mills, all these amazing scientists want to figure out what is this bacteria doing?
Yeah.
So what they do is they do another experiment. They basically take some cells from the gut, which you can take, you can culture them, and you can put them on a plate. And when you put gut cells on a plate, they actually automatically form themselves into a wall. They just self-assemble into a wall, which is pretty cool.
That is really cool.
Yeah. And so it's kind of cool because, gut cells, what they're supposed to do is basically form a wall, and anything you eat or drink has to basically go through those cells to get to your body. So it wants to make sure all the food is the right food, it's all broken down properly, all the good stuff comes in, all the bad stuff stays out. That's what the gut cells do. So they form into this wall. Yeah. Question in the audience?
If I threw up hard enough,
That's a good question.
and the gut cell went on the rim of the toilet,
Would it just automatically?
would the toilet become a gut?
I think no, but I don't know why not, because I want that to be true.
Okay.
Yeah. I think you have to feed
In the
it the
sequel.
right things. Or,
Okay.
I don't know.
Next time on Viscera.
Yeah,
Okay.
we'll try that.
Okay, but the point is, gut cells will for the experiment. You're saying sorry. I
Yeah,
just
no, it's
really
a good
wondered.
question.
So it's like a gut is being formed in a petri dish, though, kind of.
Exactly.
Okay.
The
All right.
gut's being formed in a petri dish. They
Okay.
throw some bifidobacterium on the petri dish and see what happens.
Yep.
And right away they notice that the bacteria are able to sort of latch onto the walls of the gut, just like hang there, like mountain climbers.
Huh.
And they start proliferating really fast and basically coating the whole wall.
Whoa. So that's this Y-shaped bacteria that likes the alien sugars, with enough time, it's almost like wallpaper on the inside of the baby's gut.
Yeah, exactly. It's like wallpaper on the walls.
Okay.
Okay, so they notice that, and that's interesting. Another thing they notice is, well, just like babies eat and they poop, well, these bacteria are eating these alien sugars, and they have to poop too. Yeah, so they actually
Totally.
poop.
What? I never thought. I was like, you hear about the microbiome and you have all these friends inside, but you didn't think about them.
Yeah,
needing
they have to poop.
Where does their poop go?
It just goes into the gut, goes out with the rest of the baby's poop.
Okay.
But what they're seeing is the poop that
Okay.
these bacteria are creating are acid. So they're creating acidic poop.
Huh. Okay. Is that bad?
Ba-
Does that
yeah.
burn a parent's fingers? I don't know.
Yeah, that's what it sounds bad. I'm not
Okay.
gonna lie, okay?
Okay.
Acid poop sounds bad. But what I will say, to be fair to acid,
Okay.
there's a reason, like when you go to a cookout, right? When you go to cookout, what
Yeah.
are the condiments you bring? You bring like mustard, ketchup, relish, onions. Why? Because those are acidic. And the thing is, bacteria can't really grow that well in acid. So you don't have to put it in a fridge, basically, is the idea. So acid prevents most bacteria from growing. But it turns out the bifidobacterium is totally chilling in the acid, but the idea is it may be keeping other bacteria away.
Okay, so it's this bully wallpaper that shows up, shoots acidic poop that maybe makes it harder for other
Right,
bacteria?
exactly.
Okay, so so I guess I ask again, is this a good thing?
Right. Well, we definitely know this bacteria is being territorial, right?
Okay.
It's taking over the gut. It's saying, like, this is my wall. I'm taking over.
Yeah.
And here's acid. We know that. Excuse me. But we don't know, like, if it's good or not. So to
Okay.
answer that,
Yeah.
I got to tell you a story.
Okay.
All
I
right,
love
so,
a story.
Dylan, guys, I'm going to need a little bit of, like, rogue, don't try this at home type of science music. Like,
Sign
yeah,
a
we're going to
waiver.
talk about a science story where just don't try this type of stuff at home.
Okay.
So our story centers around Dr. Shara Sheldon, who at the time is a PhD student, okay? Now, she's studying this stuff. She goes to a lecture where Bruce is talking about these results, and she sticks in the back of her mind. Meanwhile, her father is a professor at the vet school, and he works at a lab, like at the, not at a lab, at a barn that's raising these thoroughbred horses.
Ooh,
all right?
okay.
So thoroughbred horses, if you don't know, those are those really expensive horses that, they eat way better food than you and I.
Yeah.
Their lives are definitely more valuable than ours. Like, these are
For sure.
expensive
It's
horses.
fine. Yeah.
Yeah.
Okay.
But there's a problem at the barn. Every new foal that's being born to these horses, after a few days, is getting diarrhea, fevers, and then dying.
Oh.
Yeah. And that's sad because we like horses, but also sad because they're losing like hundreds of thousands of dollars every time.
On
this
every
happens.
foal. Okay. Okay.
And the problem is next week there's going to be like 20 more foals being born.
Oh no.
And yeah, so basically what they do is they find out what's going on, and it turns out these horses are infested with like one of the worst diarrheal bacteria that we have. And if anyone does anyone work in healthcare or anything like that? I mean, what's that one bacteria diarrheal illness that we don't want to deal with? C. diff,
Oh, a lot of
exactly.
C. diff.
You know it. Once
Whoa.
you smelled C. diff once, you'll never forget. I mean,
Okay. Well, it
So-
looks kind of like a dynamite stick like exploding corn dog situation.
Yes,
So what?
yes, the corn dog dynamite stick. This bacteria is terrible.
Okay.
Like you can't, if you spray this with antiseptic, if you spray it with Purell, like it won't die. Like this thing doesn't die. It's really
Yikes.
hard. It needs very strong antibiotics.
Yeah.
It kills people all the time. We see this
no.
every time in the hospital, and it was killing these horses.
And it's all over this barn.
It's just all over the barn. You can't
Okay.
exactly sterilize. Even a hospital can't really sterilize this stuff, and let alone a barn.
Okay.
So it's not a good
Famously
situation.
dirty.
Yeah, exactly.
Yeah.
So these foals infested with C. diff. The dad, who's the professor who works there, is talking to his daughter about it and commiserating. And the daughter goes, "Wait, like I just heard a lecture by this guy Bruce German,
Oh no.
and he was talking about this bacteria that coats the walls, produces this acid, is territorial. Like, why don't we? I don't know. Maybe we should try it."
Try
And,
it meaning.
like, let's give this to the horses. So the dad goes, "Yeah, I mean, they're desperate. Like, what else can we do? So
Okay.
let's try it." So lo and behold, they take the bacteria from Bruce, they culture it, they mix it up with some milk, and then when
Okay.
the foal is just born, they squirt it into the foal's mouth.
Like with a little baby bottle.
Yeah,
situa-
little baby will
Okay.
squirt it in.
Hope
and
for
see
the
what
best.
happens.
It's only $100,000 on the line.
Right.
Okay.
And lo and behold, what happens is, sure enough, 20 foals are born. None of them get C. diff. All of them do fine.
Whoa.
Incredible.
We go. Can we get a round of applause for Shara?
Rebel science.
Again, don't try it at home. Like clinical trials are good, but ingenuity. Okay.
So I want to play my interview with her because I wish I could tell you the story stopped there, but it continues on.
Oh.
All right.
okay.
Let's see.
So I was like, good job, brain, for remembering the random lecture with Bruce German.
There are so many random lectures I had in med school that I will never remember. Like, I don't know how you did that.
I loved it, though. I thought it was the neatest thing. I don't know.
Okay, so that's an amazing story, but I know that the story doesn't end there. What happens next?
So time goes on. I'm still doing my PhD and got married, got pregnant, and then I had my baby, healthy baby. Everything's going great. And then the change comes. And we started dealing with a lot of gas, a lot of crying, just like he looked like he was in pain. We were trying everything for the gas, the little gas drops that are natural, the bicycle kicks, all kinds of things. And I'm just thinking in my head, my parents told me I had colic for 9 months and was just screaming and crying constantly. So I was just thinking like, this is not good.
What are you feeling at this time?
I was very worried. I was already super tired and exhausted, and I could tell, Connor wasn't feeling well with it as well. And so I just was getting quite desperate to find something that would work. And we kind of hit the breaking point when my husband was out of town. And so I'm alone with the baby, and it was so bad. He was up like all night, just in pain, gassy. And I was like, this is not going to work. And I said, we need something. And so I remembered the bifidobacterium, and I said, I'm going to email Bruce. And so I sent a desperate email saying, please, please, I know you have some of the bifidobacterium still. Like, I'd really like to try it.
Okay, and so does he email back? Like, does he take a week to email back?
He got back to me right away, and it was such a dream. He said, you can drive up and get it. And so I loaded up in the car, drove to Davis, and went in, and we got like a little bag, just a brown paper bag, samples in there, and the
No way.
syringe.
What, they're in like little vials or something? Or like,
No, they're in little sachets, like a little rectangular packet that you like can rip
Oh.
across and pour out.
oh, okay, yeah, you got it.
So I was like,
Like a bag of drugs, basically.
yeah, you're using stuff that's being tested for research, so it's not very pretty.
Right.
I get home. I'm very excited to try this. I grab one of the little sachet packets out, and I open it, and I see there's like a powder in there. It had kind of an interesting odor, I noticed. And then I mix it in with the breast milk and then suck it up in the syringe. And then my mom helps me hold Connor, and we hold his head, and we put the syringe into his mouth, squirt it in. So we did that, and they said just do 1 dose a day. So, I'm sitting there with bated breath, waiting to see if anything happens, watching him like a hawk. And we didn't really see any changes right away. So I was a little disappointed because you're desperate at this point, right? I want results. I'm so tired.
Right.
And it took 2 days. So,
Oh.
then it worked.
Oh wow.
It was
Okay.
amazing.
What do you mean it worked? Like,
The change was just so drastic. It was like a switch had clicked. And he just was so much happier. He was sleeping. He didn't have the gas constantly and just seemed so much more relaxed. And I was like, this is working. And this is exactly what was missing from his microbiota.
well, the scientist in me has to ask, like, could this have just been a coincidence, like, or placebo effect? Obviously you really wanted to see some results. Like, how do you know for sure that this did that?
I would be doing the same thing, right? Oh, this is just a placebo, but the amount of dirty diapers had been very consistent. I had been keeping track because I love data and I'm a nerd. So I was keeping track of all of these things. And to go from like that 8 to 11 down to 2, I knew it was doing something.
Wow, I gotta say, I mean, like, was there ever a part of you that felt like afraid to essentially be like experimenting on your firstborn child, or did you just feel that confident?
I mean, I felt really confident with it. I mean, there's a small part of you that's like, oh, yeah, I'm giving this novel thing to my baby. But when I saw all the benefit, it was like, this is right, and it's working, and everything's good. But it is scary.
Oh, wow. I just have to say, is there any other like better image of sleep deprivation than like this thing smelled a little weird, but let's put it down. Such a good point. Wow. Okay, go
Yeah.
Shara. I mean, okay, but to follow up on your question there, like, do we know what it, like, is there still a chance that could have been placebo? Like, do we have
Right.
any clue about what's actually happening at the cellular level? Like, what is going on?
Yeah, so Bruce sort of made a deal with Shara, like, I'll give you the bacteria, you give me his diapers.
Okay.
Common theme we're seeing emerge here. So that's what he does. He sort of collects Connor's diapers and a bunch of other kids too, and he's sort of seeing what's going on. Let's check the microbiome, let's check the stool, see what's happening. What influence is it exerting?
Yeah.
Because, you think about it, let's look for a subtle change, like a change of 5-10% in your microbiome. When you're talking about 37 trillion, I mean, that's huge.
Yeah.
But what he finds is actually kind of insane. Like, Connor's diapers went from having 0 bifidobacterium to being 80% bifidobacterium.
Whoa.
This is a graph right here. You can see the blue is bifidobacterium. It just crowds everything else out
Wow.
pretty instantly. And this is like insane because, this isn't normal microbiome stuff. This
Yeah.
isn't like diverse ecosystem. This is just like domination by
It's like a
one bacteria.
monoculture in there.
Yeah,
It's all
exactly.
bifid. Wow.
Yeah. And the other thing is, we talked about these bacteria, they poop themselves, they poop acid. And there's just so many bacteria in there that the baby's poop is literally becoming acidic.
Huh.
Which is kind of crazy, right? Because if you were to look like go to LabCorp and say, what's the normal pH for, baby stool? They would say 7, which is water, which is, neutral.
Okay.
It's neutral. But they're finding the acidity is like getting down to like 5, on these stools. So it's a little concerning. So
What's five's like what?
5's like maybe like vinegar or something like
Okay.
that.
Oh, okay.
I don't know actually, something like that. So it's kind of concerning. So they decide to look into it. The team looks into it. A student by the name of Bethany Henrik, who's now a well-established PhD herself, she decides to sort of go back in time and say, like, well, where did this come from? Where did baby stool being 7, being neutral, being normal, where did that come from? Let's who said that?
Okay.
Basically. So she decides to basically go back and look at every scientific study that ever put a pH probe into a baby's poop.
Okay. Does she have much to work with?
Right. I mean, that's like I'm just curious with the audience, like, how many times would you think that's happened? This was invented in 1909. So.
Okay. That we could measure pH.
Yeah,
Okay.
like twice.
Twice?
I don't know. 200? Well, that's good. It actually happened 18 times in the past 100 years. So
Okay.
1909, this is invented. It took until 1917 for the first scientists to put that into poop, to baby's poop, and they've done it 18 times since. Okay. And here's what they find when she goes in through the data and looks at like every baby and maps it out and graphs it out,
Yeah.
is that there's this very clear line. And it's showing that basically our baby's poop used to be acidic to a
Okay.
pH of 5, which is acidic.
Okay.
And it's slowly been working its way up to neutral. And it's like this very clear thing if you map it out.
Huh.
And yeah, it's kind of crazy. It doesn't sound like much, this line doesn't look like much, but that actually represents like an 80-fold difference in the amount of acid that's in baby poop. It's huge.
And again, you said the bifid makes the acidic poop, so watching it get less acidic, is that like watching a disappearance?
Exactly.
Okay.
That's at this point, Bruce and the team is sort of being like, wait, this is a sign. This is the marker of bifid, and it's going away. That's what they see.
Huh.
So they want to figure out, okay, there's these acids, blah, 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 that's kind of crazy, but like what exactly is going on? Like, what acids are they actually making?
Yeah.
And I'm going to geek out for a little bit. The chemistry people will like me. Everyone else might hate me, but just stick with me because I think this is cool. All right, they find out that the bacteria is producing 2 main acids. One's called acetate and the other's lactate.
Okay.
Okay, so acetate. Acetate is known as a short-chain fatty acid.
Okay.
All right, and what that is basically a small miniature fat that we can't make, but we can't really get it in many places in nature, but this bacteria is making it. And it just so happens that those gut cells that we talked about, that wall of gut cells, like this is their favorite food.
The gut cells like to eat.
Yeah.
Okay.
Like they want to eat this themselves. Like I
Yeah.
mean, if you took the gut cells to their favorite Michelin star restaurant,
Yeah, this is what they choose.
like they would, or this would be the calamari for them. This would be the thing they want.
Yeah. You don't think about them eating. You think about them serving you, like breaking down and giving you the nutrients you need. But they
Right.
need to eat too.
Exactly.
Okay, so that's what they eat to
Yeah.
do their job. Okay.
Especially in babies.
Okay.
These gut cells are growing
Yeah.
so fast in a
Yeah.
baby, they get very hungry. So as they take in food to give to the body, they like to take a little for themselves.
Yeah.
So when there's acetate, they love that.
Okay.
The next molecule is lactate, also
Okay.
known as lactic acid.
Okay.
So this is also interesting because it turns out that your nerve cells, your brain, nerve tissue that exists in your gut and your brain, they actually can't use glucose.
Huh.
I don't know if you knew that. They can't
Definitely
really use
didn't.
it.
Your brain just can't do anything with normal sugar.
Yeah, it's too busy thinking to use glucose. It doesn't have the time for that.
Okay.
So that's why brain cells are always surrounded by support cells. In the brain, they're called glial cells, whatever. There's these supporting cells. It just
Okay.
so turns out, by the way, side note,
Yeah.
is like the only thing that made Albert Einstein's brain different than ours
Yeah.
was not the amount of brain cells, but the amount of support cells that they had.
Huh. It
Glial
was the
cells.
scaffolding.
Exactly.
Okay.
So what these support cells do is they take the glucose, they do some chemistry, they change it into lactate and pass it to the nerve cell.
Okay.
So lactate is a nerve or neuron or a brain cell's favorite food.
Okay, I'm feeling a recap. Okay, so really quick. So we were talking about breast milk, the weird alien sugars, which feed the bacteria, the bifid, the Y-shaped thing, which itself poops acid, specifically, which is these 2 things, which fuel the baby's digestion and thinking?
Yeah.
Okay.
Yes.
Thank you.
Oh.
I listened.
Let me just summarize it too. Let me just
Okay.
draw out a picture of what's actually going on in the gut.
Oh,
So
okay.
this is a baby gut under normal circumstances, like my gut, because
Okay.
I don't have this or whatever.
Okay.
So when you have, this is the wall, this is inside, that's outside.
Okay, wait, the top's like the tummy where stuff's coming in?
Yeah, exactly.
okay.
So this is the gut cell when there's just normal adult bacteria, E. coli, your regular stuff there.
Okay.
Those bacteria secrete toxins that basically poke holes in this wall
Ow.
and allow things to pass through. Instead of going through the cells, they sort of go in between the cells and around the cells. So bacteria can get in, toxins can get in, undigested food particles could get in.
Ugh.
And and that's called leaky gut.
That-
Okay? Those things get into the body, and for this baby that just got an immune system like 2 months ago,
Yeah.
is trying to figure out what the hell is going on, and it gets very overwhelmed and confused. It gets inflamed. The immune system is hyperactivated, and it causes a lot. It could cause a lot of problems. Now, on the other hand, when bifidobacterium is here, the bifidobacterium sticks to the walls, prevents any other bacteria from coming there, and the food it's releasing is just strengthening these cells, making them super strong and super tight, so that basically nothing bad gets into the body, and the immune system can actually learn and do its thing.
Like
not
learn
get-
self versus other.
Yeah,
Okay, so the top
exactly.
there, that's our wallpaper. That's the bifid wallpaper.
Right.
And everything just seems to be like the gut cells are more well fed and they're able to distinguish, like the bad leaky gut isn't getting in and the immune system is maybe having an easier time because they're less foreign things.
That's the idea.
It is I don't know if it's sounding this way to anybody else. It's sounding like bifid is good.
Well, that's the idea, and that's certainly what Bruce thinks. At this point,
Okay.
Bruce goes from being just a normal scientist, show up to work, do your research, to becoming like a borderline evangelist.
Okay.
Like his daughters won't take him to the family dinners because this is all he talks about. He told me that.
Okay.
He's he sees a baby in a stroller across the street, he's gonna sprint over to the baby, throw some bifidobacterium at him.
Okay.
And he actually mortgages his house and gets his coworkers to do the same. They sell the boat, do all these things to start their own startup to sell bifidobacterium.
Whoa.
Right.
Okay.
Which you can buy and which we may or may not have. We
Ooh.
could try.
And this is just like he's selling bacteria in a jar?
Bacteria in a jar.
Okay.
Yeah.
Okay.
So that's where they're at. And he's telling everyone he can find, and so is his team. So someone on his team eventually runs into a guy by the name of Brian Scottolini.
Okay.
Brian Scottolini is an MD, PhD, overall genius, and he's a neonatologist who works at OHSU in Portland.
Okay.
Okay, so he's working there, and as a neonatologist, it's a beautiful thing because you get to see these little tiny preemies grow into full-fledged adults. But there is one thing that's the worst thing that happens in NICUs, and basically that's this. Okay.
What are we looking at?
So what we're looking at is a preemie's belly,
Okay.
and it's filled with gas, it's very distended, and this baby's not doing well. This is called necrotizing enterocolitis, also known as NEC. And basically what's going on is a bacteria, an adult bacteria, has somehow made its way into the baby's gut, has sort of bloomed and taken over, and is completely destroying the gut wall, producing all this gas and all these bad things.
Huh. That looks painful, scary. I mean,
Very scary.
Yeah.
Yeah, I mean, when I was a resident, I rotated in NICUs, and it's terrifying because these preemies can go from being normal, they're doing well, and then overnight, they can totally crash, get this, and the mortality is very high once they get this.
Yikes.
So Brian gets sort of wind of this bacteria, and they both have this thought, well, maybe we could try bifidobacterium
In the preemies.
in the preemies.
Okay.
So he makes a move that's pretty, I think, gutsy.
Yeah.
No pun intended.
Okay.
I honestly
That
didn't
one
even
was
plan
not
that one.
tested in rehearsal. When we were in a heavy situation. Okay, keep going.
So
Avir's
he
going to
makes
drop
this,
a pun in there. Okay.
Yeah.
All right.
So he makes this move. He basically goes back to his hospital. He gets some of the bifidobacterium from Bruce and the team and the company, and he just starts. He tells the nurses, "Hey, we're going to start giving this to the babies tomorrow. This is
Oh
what
my
we're going
gosh.
to do."
Without checking with parents or
Right, pretty much this is on formulary now. We're going to give it to them.
I'm having mixed emotions about this idea.
Sure.
But, okay.
Yeah, I agree.
Okay.
So he does that, and you got to think he's not just waiting till they get NEC to give it to them.
Yeah.
He's giving it to all the preemies, even the ones that would be fine without it.
Like
So
a preventative measure. Okay.
Exactly,
Okay.
preventative. Okay, so he does that, and lo and behold, he finds that the incidence of NEC goes from 11% down to 2%.
Whoa.
Insane.
That's huge.
Yeah.
Okay.
And this goes on for years.
Yeah.
There's, in fact, years that go by that they don't see a single incidence of this
Of neck? In
Right.
the NICU?
in the NICU. He publishes about it,
And he's
gains some
sprinkling
momentum.
Bifid this whole time.
Yeah, it's just
Okay.
sprinkling.
Okay.
This was in, well, we'll get to that in a second because I don't remember, but he will. So he does this, and yeah, pretty incredible. And yeah, he finds that it's working. Other NICUs are starting to take this up. At this point, as it's going along, that up to 15% of NICUs are doing that.
Wow. Okay.
Yeah. So anyway, I've been talking about Brian enough
So
to
yeah,
answer
what
to your
happens?
question.
Wait, what happens?
Well, I want to bring Brian up himself. So if Brian,
All
if
right,
you're here,
let's
let's
get some
bring you
play
up.
on music. Come on down.
Thank you, Brian.
Hi, everybody.
You just flew in today, just landed.
I did.
So you had this really incredible result when you studied bifidobacterium. I mean, truly incredible, and it seemed like it was spreading. But I guess I wanted to ask you, like, what happened next?
Well, as Avir was saying, for years, our incidence of necrotizing enterocolitis was quite low. And as a scientist, I was waiting for a day or a week when babies would start having it again, and that the result that we thought we were seeing wasn't true. But it just went on for 5 years. So we started in 2018 to answer that question, and then we had to stop in 2023.
Tell me about that.
So for years, even well before me, neonatal intensive care units throughout the world, in Europe and in some places, like in Australia, almost every premature baby gets a probiotic, gets a bacteria that is like this, including this one that we were using, Bifidobacterium infantis, to prevent necrotizing enterocolitis. So I wasn't as crazy as it might have sounded to start using it in our NICU.
A little crazy, a little crazy.
But we were the first ones to use it alone. So our team decided this bacteria makes sense because of its symbiosis with milk, because it's for millions of years co-evolved with milk. It's ditched antibiotic resistance, it's ditched invasiveness, pathogenicity. It's given over 15% of its genome to do symbiosis with milk. And so we thought we should use this to prevent necrotizing enterocolitis. But what happened, as you might expect, whenever you introduce a bacterium into somebody, whether it's us or babies, and especially babies with an immature immune system, there is a risk that it will find its way into their bloodstream. Now, if you ask me if I'm going to choose between a pathogen and Bifidobacterium infantis, which has no antibiotic resistance, doesn't have sex with other bacteria, and is meant to be in milk or in the gut to metabolize HMOs, which cannot be metabolized by us, remember that, I will choose B. infantis. And so, unfortunately, some babies got B. infantis in their bloodstream and had positive blood cultures, meaning that when they looked ill, they had a sample of blood taken and then was grown to see if B. infantis was there. I might add that other bacteria that have been used as probiotics have also found their way into the bloodstream. The FDA knew that NICUs throughout the United States were using this to prevent necrotizing enterocolitis, and decided, with the instance of a bloodstream infection with B. infantis, that all the NICUs in the United States needed to stop using probiotics to prevent necrotizing enterocolitis. This essentially was like a cease and desist letter. You can read this letter and see there isn't a hospital in the United States, a risk department in a hospital that's going to continue to use this with the FDA saying you shall not use this without a investigational new drug status.
So you get this letter, and I imagine you have some complicated feelings, because it's like, I don't know, we could understand where the FDA is coming from.
I'm a little inside FDA.
But at the same time, you're working hands-on with these babies, and you're seeing amazing results. So, like, what's going through your mind?
The first was, oh, crap. But a stronger word than that, because we know in the risk-benefit, we saw necrotizing enterocolitis, we'd get 2 or 3 babies die per year. And for several years, no baby that was born in our hospital died from necrotizing enterocolitis. And we had no baby get bacteremia, having bacteria in their bloodstream that was B. infantis, even though we knew that that was a risk. So on one hand, I felt like babies were going to die now throughout the United States, not just at OHSU. I hate this disease. I can't tell you how much I hate this disease, and I hate seeing babies die in 4 hours, 6 hours, they're dead. And the impact it has on their parents, and their whole lives have been lost, versus a rare risk like this. So that was going through my mind. But on the other hand, it was sort of like what you were talking about, Lulu. It was sort of like, well, we were using something to treat, prevent, or mitigate a disease, which is a drug. And therefore, I see the FDA's point. So I was split minds.
Yeah.
What happened once you removed this bacteria?
Unfortunately, we're working on reporting this, but our necrotizing enterocolitis rate has come right back to where it was before. In fact, probably a little bit higher than it was before.
So I guess where do you go from here? What are you trying to do now?
Well, we suspect this is happening throughout the United States, so we hope to be one of the first to report this. But since that time, we've been working with the FDA to try to have this become a drug, which is not the most simple pathway. And for some in the audience, you probably understand that like it costs a lot of money to develop a drug, and that's for adults. And adults vote. Premature babies don't vote. Investors are scared of premature babies. They're afraid of pediatrics in general, and they're really afraid of preterm babies. And so it's a struggle to try to make this continue to move forward. And the only thing that keeps the folks who working on it as a large team is the fact that it, at least in our hands, it works.
Amazing. Okay, Brian, stay here on stage. Thanks, Brian, for being here.
Yeah.
Okay. So just to advance the story from here, Brian gets this result. Bruce has this company. He still really believes in it, but unfortunately his company sort of now has a scarlet A. You know, it's not doing so well. They're basically heading towards bankruptcy, and they have to sort of short sell to a private equity to stay afloat. And so Bruce and his team sort of lose stake in the company. They're still, he still has his job. He's not like on the streets, but things aren't looking too good. But Bruce still, and I've spoken to Bruce for hours. He is never negative. He's still positive about it. He's still hopeful. And I'm like, but Bruce, like what? He still feels like this is the right thing. I got to do it. And so anyway, I've been gatekeeping this guy, Bruce, long enough. Let's bring him up to the stage. Bruce German. Hi. I met you for the first time today, but I feel like I'd known you because we've been talking so much, texting all night long, like we're teenagers or something. It's been kind of crazy.
Daughters warned you.
Okay, Bruce, I've got a question. Going all the way back to that global poop hunt, I don't know if that's what you called it in your papers, but our shorthand, do we have any clue, like, why in the places like Denmark and most of the U.S., except the Mennonite communities in Switzerland, like where was the bifid going? Why did we lose it if it seems like it is such a harmonious thing in a baby gut?
Excellent question. First, I should say that this is the work of literally over 100 people for 20 years. And I know I'm obviously distractingly tall and good looking. But really, it's this diversity of scientists from around the campus of UC Davis have brought this science forward. And that's one of the critical questions where you need multiple disciplines. Because remember the genius. It's a mutualism, what we would call a synergy. It's 1 + 1 isn't 2, it's 10. It's truly a complementation. And that means you need both. Oligosaccharides don't do much by themselves. The baby poops them out. Bifidobacteria infantis doesn't do much all by itself. The baby poops it out. But you put them together, and that's the magic. And away it goes.
So where did it go?
We didn't invent it. It's been in babies, but babies are born sterile.
Completely? No microbiome in there?
They're sterile.
Thing?
Mother, you are keeping your baby sterile.
Huh.
But needless to say, the minute they're born, they're being inoculated from bacteria all over.
Wow.
If there's no Bifidobacteria infantis in their environment, they cannot get Bifidobacteria infantis. And so now we begin to look, where could it go? Well, if mothers can't breastfeed, then they don't get the oligosaccharides, they don't survive, no Bifidobacteria in the baby.
No fish food for the bacteria. Okay.
Nothing. If the mother gets antibiotics, kills the Bifidobacteria, and that mother will never have bifidobacteria again unless she somehow gets re-inoculated.
Whoa.
So it's one step in any of those directions ends the story. And it's been happening over a century. So gradually, as the pH results indicate, mothers are losing the ability to pass on the bacteria.
So, another part of this is formula doesn't have these alien sugars, and it's
No.
not able to feed these bacteria, so the bacteria get starved. And I will say, you won't admit this, but part of his evangelism was that he would email all the formula makers and be like, "Can I meet with you?" And he would get some meetings with these formula makers and just go on in these boardrooms about putting HMOs back into the bacteria. And my impression was they were sort of like, "Thank you, sir. Here's security. Please leave." I'm exaggerating, but lo and behold, a few years ago, all the major formula makers have added these alien sugars into the formula.
Okay, you told me to bring formula. I didn't know
Yes.
why. Okay. This is
That one. So
And
yeah,
where-
you can see.
okay.
They spell it wrong. They spell it
Oh, the HU, that's the HMO, that's the alien sugars.
Yes.
Exclusive. HMO.
Yes.
Whoa.
I'm crediting you with that.
Well, I mean, it turns out that there are dozens.
That's great. That's great.
There are dozens of different oligosaccharides, and so far, industrially, they can only make a couple. And so formula has not got the diversity that you would like, and you need a lot. Remember, you pointed out, there's more of this than protein. Evolution's saying it's as important to feed the bacteria in the baby as the baby.
Right.
So we need to get a lot more to be able to match.
Okay.
I mean, breastfeeding is the genius. If you look, it's a mother's ability to breastfeed that makes all this possible.
And another thing that changed is the pH scale for baby stool also changed as a result of all this work, that now normal is not just considered 7, it's anywhere from 5 to 7. So science is starting to catch up to this, I think. Okay, well, I think one question I had is sort of, you look at that graph of the pH changing and the poops changing over the centuries. Like, I can't help but think this correlates so well with the rise of like childhood autoimmune diseases and like these chronic diseases. I just wanted to, is there something there?
Yeah, we've been studying that, and it turns out that, I mean, the immune system is just a magical system. The strength of the immune system is it's so personal. You're not born with an immune system, it has to develop. And the benefit of that is your immune system can learn to attack diseases your parents never had. So the ability of the immune system to develop that individual capability, magic. There's a flaw, is your immune system has to develop, be educated in the first few weeks of life. And the immune system is basically located in your gut for sort of obvious reasons. It's paying attention to the environment through the bacteria. If the bacteria are appropriate, Bifidobacteria infantis, then it's clear that the immune system is developing appropriately. But if the gut is full of inappropriate bacteria and negative, gram-negative, and our bacteriaceae are blooming occasionally, now the immune system is being miseducated. The result of that is, with Bifidobacteria infantis, it's clear it's an intelligent immune system. If it doesn't, then it's not an intelligent immune system.
What does that mean, intelligent immune system?
It makes mistakes. So immune system can make two kinds of mistakes. It can say, there's danger, don't worry about it. The other kind of mistake is, it's perfectly benign, I should attack it as if it was dangerous. And that's what autoimmune disease. There's over 70 autoimmune diseases, but it's sporadic, chaotic. When someone doesn't have Bifidobacteria infantis, their immune system is not developing appropriately. That means it's greater risk. Doesn't mean they're going to get autoimmune disease, but they're at greater risk of having it. But that means at a particular point in time, when they should be deciding this is perfectly appropriate part of me, self, a bloom of the wrong bacteria, danger, and for the rest of your life, you think that's dangerous. If it's peanut butter, it's peanut butter. If it's pollen, it's allergy.
Pollen.
Yeah.
Gets
Yeah.
me every time.
Yeah.
So we now have very convincing data that a part of the problem with autoimmune disease is the bacteria in your gut in this early developmental stage. And lo and behold, throughout human history, Bifidobacteria infantis, that's been the one.
Wait, I'm having a deep thought. Can I share? Can we get some like deep thought music? I need some, you know?
Okay.
Oh, let me go back, you know? Okay, I'm just trying to put this together. It's
Soliloquy it up. Go up. Go
okay,
up stage.
okay.
Go
Soliloquy.
up. Go.
Oh, I feel like I'm in middle school, like giving a presentation. But, you know, I just think it's crazy that there's this like Y-shaped bacteria, right, that no one ever paid attention to, that we almost wiped off the face of the earth by accident, that basically has this completely symbiotic relationship with us. I mean, like, you know, we obviously in school we learn about like the birds and the bees and pollination and coral and algae, but like, who knew that like our babies have symbiotic relationships with this random bacteria? Like, that's Sylvie, that's Lulu's
My baby.
baby. Like, Sylvie is a symbiote with this bacteria. I mean, it's blowing my mind. And if you really think back, like, if you really go back in time, let's go back 500,000 years, which is when we broke off from primates to become human. Bruce was telling me if you go back, you know, trace the genetic lineage of Bifidobacterium infantis, it broke off from its predecessor at exactly the same time, which to me is crazy, because that means like we have literally co-evolved with this bacteria. I mean, like, come on, like this is our best friend. This is like our oldest and best friend that we've ever had.
Okay, Avir, can we scratch the emo music? Okay,
What?
I mean, you put a picture of my baby up, and I might say it's a beautiful thought, but you've gathered like a sad story here. I mean, Brian was shut down. The study was shut down. Who knows how long, if it's ever going to go. I mean, Bruce is eloquent, but his business sounds kind of on the rocks. And I feel like, and then even if we could get it back, there are all kinds of parents who can't breastfeed for different reasons, economic reasons, body reasons, whatever it may be. So, like, aren't we just being kept away from this majestic, beautiful friend? Isn't this just sad and we're doomed to be unhealthy?
At this point in time, no. If
Okay.
you look back at the history of scientific discoveries, especially related to health, they're always turbulent. This is a fundamentally different way of thinking. Historically, the way you treat your baby is you keep it away from bacteria of any kind. You keep pathogen, you scrub them, and we now realize that that wasn't the whole story. But if you look back how science moves, it's moving inexorably forward. It's just a matter of time. And if you look at all the things that milk has taught us, and now we're realizing that mothers are doing this remarkable thing. What you're doing is feeding the baby and feeding this bacterium, which acts like the perfect nanny. It nourishes the baby. It guides the development of the baby. It protects the baby. It fuels the baby. All those are clearly benefits that not only did we not know about, we didn't measure babies enough to be able to say, oops. Yeah, in 100 years, 18 papers on poop pH.
And that, to me, that seems like a lot. Like, I would have been fine with 5. I don't know why they did this 18 times. But I mean, I guess, are you seeing like this future, like, are we gonna live in this future where instead of taking like antibiotics, getting a prescription for antibiotics, we're gonna be getting a prescription for bacteria? Like, you need like 10 gallons of this bacteria stat.
Yeah, well, think of what this is doing for the baby. It's nourishing the baby, protecting the baby from pathogens. It's guiding the immune system in ways we didn't even think about before. It's now been shown that babies with Bifidobacteria infantis respond better to a vaccine than babies who haven't. So that's not just protection, that's enhancing health in ways we didn't even think about before. That this is just plain healthier. Now we know what healthier means. Your immune system is exposed to a pathogen. It builds antibodies. If the gut is helping, the bacteria are helping that immune system, then it makes more antibodies and more diverse antibodies. You're better protected.
Okay, this guy can milk hope out of any situation, I guess.
Another pun. Well, I guess with that, we only have one thing left to do, honestly, is we got to start this now. We have the bifidobacterium here. We're
Bifid
going
in
to
the
try
house.
some.
Yeah.
No pressure, obviously, but if you guys want to try some, we can all cheers to Bifid together. Just talk to your bartender. They're going to be bringing them out.
Passing it. Raise your hand if you want it. Once again,
yeah.
you do not have to. Radiolab doesn't necessarily condone it. This is going to take a
This
second.
is not my medical advice. You can't sue me if something goes wrong.
I kind of think we need music for this section.
We need some music.
And I think we need to bring in an instrument that has never been played on Radiolab ever before. Hold on. Can you mic me?
Yeah.
My breast pump! Okay,
Breast
ready?
pump remix.
Come forward. Okay, ready? We might, because it does make a noise. I don't know if you guys know this noise. Ready? 3, 2, no, put it there. Yeah, go.
Very goth, industrial goth vibes.
Yeah, it's like a little steampunk. Oh my God, this sound. Again and again. Why capitalism? Why?
Don't drink it yet. We're gonna drink it together. We're gonna drink it together.
Lay down that funky beat. I promised I wouldn't freestyle,
Oh, really?
and yet I'm feeling a little bit cheerier because we're about to all eat bacteria. Okay, I think I'll keep it at that. Who hands up that still need the bacteria? Hope no one gets listeria.
I'm gonna get you on SoundCloud.
Based on Bruce's theory that this is gonna bring us all into harmony. Okay, that's all I got. I don't know.
All right. Everyone got a drink?
Not gonna quit
One
the
more.
day
One
job.
more. One more in the back.
One more hand in the back. Everyone get your bacteria ready. Okay, can we get ours? Okay, we're gonna just keep the music going. Okay, now everyone.
Let's
okay,
turn
we're gonna
that
bring
music
it
down.
Okay.
All right.
All right, music is everywhere. So let's raise a toast to use the microphone because I'm an audio professional. Okay, let's raise a toast to humanity's oldest friend.
All right. Cheers, everyone.
Cheers! Okay, we really do it? Okay.
What did we actually drink just now?
Straight up bacteria. Who just asked? Yeah, you just ingested, I don't know, is it powdered, dried bacteria? It's those little Y shapes. What did we drink, Bruce?
Yeah, Bifidobacteria longum subspecies infantis.
Okay. Okay, so now we're gonna.
We gotta open it up to questions.
Now we're gonna
I'm
do
sure.
a brief Q&A before we get out of here. So, okay, I guess I should bring a microphone around. So I heard one over here, which was,
Is it effective with adults as it is with infants?
is the bacteria as effective with adults, or at all effective with adults? I'll come to you.
No, it's a great question. In order for the bacteria to grow and stabilize and start producing the acids, etc., it needs human milk oligosaccharides, which you did not have.
But
Will
there,
we all be
If you want to start
pooping
drinking breast
acidically
milk
tonight?
every day,
folks are examining it together with milk oligosaccharides to prevent C. diff disease, as we talked about earlier.
Okay. We got one over here, Bruce? Or Bruce and Brian, for both of you.
So at the beginning, they were talking about the thousands and thousands and thousands of bacteria, and the researchers were going along and checking each one that they found until they ran into this one. Is there a chance that there's more that we haven't gotten to yet, or did we just stop there and that was the end of that process?
Great
No,
question.
That's a wonderful question. We have a job waiting for you. In fact, we have broadened it. Back in 2004 and 5, when this was starting, the tools to examine bacteria were nothing like they were today. Intelligence itself was stupid. Now, the capabilities to look at entire clades of bacteria simultaneously for their ability to digest these oligosaccharides. So it is as rare as we just got lucky. We found it. It was in a library from a breastfed infant. it's been predicted that if we had not found it, it would probably have been extinct within the next generation. And then we found something that wasn't there. In a Sherlock Holmes sense, it wouldn't have been findable at all in a few years. So just and again, this is the consequence of evolution of mothers and milk. They get the credit, not us.
Any other questions?
We got one over here.
So the bacteria needs the HMO to live, and the baby is born sterile. Where between the stage where they're born, getting mother's milk, and the stage in which the mother's passing it on, how do they survive?
The bacteria?
Yes.
Yeah, I mean, the bacteria itself, we think throughout the last 500,000 years, has been living in babies. Remember, throughout human history, no diapers, no hygiene, no antibiotics. And what's the first thing you do with a baby? You pick it up. We were all, anthropologically speaking, pretty much covered in B. infantis all the time. So there wasn't a problem of moving it along. And within hours, every baby was acquiring Bifidobacteria infantis. And as soon as they do, as long as there's breast milk, then away they go. It is an amazing thing to watch.
You can also find B. infantis in the vaginal tract of women in the countries that have an abundance of it in the baby's poop. So they get inoculated with it as they are born.
What do they survive on in there? Because
It can metabolize other carbons. It's just the only one that we know of that can metabolize all of the dozens. There are somewhere around 90-ish HMOs of different types.
I got the note that we only have time for one more, and it's going to be right here, but because I have the microphone, I'm going to sneak one in. Okay. So this wallpaper idea, that it's helping the baby sort of understand what is self and not self, that with immunity, the wallpaper, the barrier, makes that a little easier as it's trying to learn so much. So this is sort of an emotional question, but in this moment of breastfeeding, which I have found to be one of the most connecting experiences of my life, you're saying what's happening is the baby, which used to be inside me, is learning. It's building itself away from me, from other things. It's actually a physiological moment of a wall being built of disconnection.
Well, it's true, but but you're paying forward so that infant can be successful. The genius of milk is we tended to think milk is protective, of course. Darwin, survival. It's more than that. Evolution is driving not just survival, it's success lifelong. What you're doing is providing the means for your baby to be successful its whole life.
Yeah, blah, blah, blah. Give them roots and wings so they can fly away. I only heard the first part. I'm sad. Go evolution. Sorry. Okay. For our last question here.
Hi, thank you. This is so wonderful. I'm curious, since your efforts were sort of thwarted with, distributing bifida as a treatment, have there been any clinical trials that you're aware of that are trying to get bifida passed by the FDA as a drug, as a treatment?
So there is a reason why there is an FDA. If you think about things like snake oil or other things that have been sold in the past to do things that they don't do. So the FDA is it may sound like I'm just shilling for them, but my interactions with them thus far, and I am a biochemist, I have not interacted with the FDA before this, but there is a reason why they exist. They're there to make sure that what we have as drugs are efficacious and safe, and that we understand what the risks are with those drugs. We were in this position where we knew something might work to prevent a disease that's horrible, and knowing that in general it was going to be extremely hard, if not impossible, to get the money that's necessary to do that. It always comes down to dollars, unfortunately. Even the research I do has to be resourced by that. So the the field found itself using it as a food because it's used as a food elsewhere in non-medicine. I mean, there's people in the room who are probably taking probiotics right now. And so we thought, we're going to do this because there's a signal that it could be efficacious. Now in the setting of risks that are somewhat defined but need to be defined, that's where the FDA came in and said, if we're going to do this, we got to do this the right way. And so we're working towards that. It's a very long process. It's kind of exhausting. There's some confusion about where we go right now because there's been such change in the FDA, but we will continue to bore forward to get clinical trials put together that will see whether or not this is efficacious and safe, and we won't give up very easily.
That's great. The, dare I say, the perfect cocktail of risk and safety. Okay, well, it is time now. As we said, this is a live podcast taping, so we got to do the credits. Someone once said if you want to hide a piece of information, put it in the credits to a podcast, because no one will listen, and yet you're all stuck here. So, huge thank you. He's not even on here, but to Avir Mitra for bringing us this story. To Bruce German. To Brian Scottolini. Right here on stage. To Shara Sheldon and all her hijinks. To our musicians, Dylan Keith and Yvonne Bonbonburn. Biggest thank you to the Radiolab team lurking in the background. Stand up. Harry Fortuna, Sarah Sandback, Soren Wheeler, Pat Walters, Anissa Vitsa, Jeremy Bloom, and George Wellington. Speaking of Radiolab, I would like 2 OG members, Robert Krowich and Ellen Horn, to stand up. Our original executive producers. They are here. We love you. None of us would be here without you. Everybody here at Caveat, thank you for bringing us here. Tip your waiters. Order more drinks. We would love to come back. And finally, of course, to our Radiolab members who said there are people watching us on a screen. Hi, if anyone's still there, thanks. You make everything we do possible. And now, Avir, you have a couple, and I need someone else to read the very last thing. We need a listener. Anyone, an audience member willing to? Okay, come on down.
Some quick thank yous. This story actually came to me from a Radiolab listener named Tim Brown.
Woo!
So cool. So thanks to him for sharing this story. David Mills, Carlito Labrea, Bethany Henrik, Danielle LeMay, Katie Hind, Jennifer Smilowitz, Angela Zivkovic, Daniela Baril, and Mark Underwood, all the scientists involved in this research that I wasn't able to shout out before.
Hi, I'm Alexa Petrie, and I'm from Halifax, Nova Scotia, and here are the staff credits. Radiolab was created by Jad Abumrad and is edited by Soren Wheeler. Lulu Miller and Latif Nasser are our co-hosts. Dylan Keefe is our director of sound design. Our staff includes Simon Adler, Jeremy Bloom, Becca Bressler, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Namasambandan, Matt Keelty, Annie McEwen, Alex Neeson, Sarah Kari, Sarah Sandbeck, Anissa Vitsa, Ariane Wack, Pat Walters, and Molly Webster. Our fact checkers are Diane Kelly, Emily Krieger, and Natalie Middleton.
Well done. Thank you all.
Thank you so much.
Have a great night.
Yeah, you guys say